Trigonometry. We are doing notes part 2 for our unit on ST1, which is similarity in trigonometry. So today we are doing similar polygons. All right, the second slide. Similar polygons are polygons whose corresponding angles are congruent and corresponding side lengths are proportional. So think of when you are scaling an image and you don't want to distort anything. Those are similar. All the angles and facial features are in the right proportion. It's just that things got smaller or bigger. So these two polygons are proportional and similar, and they're listed down here. This symbol is the similar symbol. It's located over by the Q on your keyboard if you need it. So QRST is similar to ABCD. This works just like triangles did, where the Q goes with the A, the R goes with the B, the S goes with the C, and the T goes with the D. Those are the corresponding angles. Okay, so for this similar polygon, what are the corresponding angles and what are the ratios of the corresponding sides? So we're going to do corresponding angles first. So let's see, angle Q is going to correspond with angle A. Now these are congruent, so if you're handwriting, use the congruent symbol. If you have the time, you can go up here, right here where it says f of x, and you can use there's an actual typed congruent symbol in there too. So Q goes with A. R goes with B. Angle S, right? Angle S goes with angle C. There's also an angle symbol in that f of x. Right now I'm just using the less than symbol. It doesn't look quite great, but I don't have my stylus with me today. Alright, so those are the four pairs of corresponding angles. Angle Q is congruent to angle A, and so on. Then the ratios of the corresponding sides. So I'm going to start with the ratio that's not simplified, and we'll get there. So if I do the long side first, 36 corresponds with 24. And then I'll go around. 18 goes with 12, 24 goes with 16, and 19.5 goes with 13. So now those ratios are not simplified. If we simplify them, like what numbers go into both 36 and 24? We can divide both of those by 12, so it's going to be 3 to 2. 18 and 12 can both be divided by 6. 3 to 2. 24 and 16 can both be divided by 8. 3 to 2. Well, what about 19.5 and 13? I don't know. But I bet it's 3 to 2. So if I divide 19.5 by 3, I get 6.5. And if I divide 13 by 2, I get 6.5. So this is also a 3 to 2 relationship. I'm actually dividing both of those by 6.5. Because 19.5 divided by 6.5 is 3. That's kind of a weird one because we don't have to do that with decimals. But you can see that they're all in the same ratio. So not only are the angles congruent, but the sides are all in the same ratio. So that has to happen for these to be similar. If one of them's out of whack, the whole polygon's off. It's not similar. All right, identify pairs of congruent angles. Write an extended proportion that relates the corresponding sides. Okay, so let's start with the angles. Angle J is congruent to angle D. Angle K is congruent to angle F. Nope, that would be angle E. Watch the markings. Angle L is congruent to angle F. By markings, I mean these arches. The two go together, meaning they're congruent. Write an extended proportion that relates to the corresponding sides. include that in the similarity statement. Okay, an extended proportion that relates the corresponding sides would be like 12 to 20 to, I'm going to have to use a root symbol here. Root 544. No. Root 544 equals, nope, I want to get out of there. And then we do the same thing on the other side. What goes with 12? 9 goes with 12. And what went with 20? The 15 goes with 20. And what went with the hypotenuse? So the hypotenuse was the root 554, and the hypotenuse of the other one is root 306. Root 306. Okay, so that's an extended proportion being set equal to each other. And then include a similarity statement. So here you're going to draw a triangle, and you're going to say triangle JKL is similar, use that tilde, to triangle. J goes with D, K goes with E, and L goes with F. Okay, so then we have a scale factor. So not only are they similar, but what is the scale factor that they're increasing by? Okay, so the scale factor of this first one moving to the blue one. So from red to blue, the scale factor is 2/3. So if you multiply each of the side lengths on the red triangle by 2/3, trapezoid, you get the answers from the blue trapezoid. To go the other way, you have to multiply the blue trapezoid by 3/2, and then you get the results in the red trapezoid. So if you multiply by a factor less than 1, your shape is going to get smaller. And if you multiply by a factor greater than 1, your shape is going to get larger. Okay, so scale factor is the factor that you multiply each side by to obtain the new side. Okay, so we're going to do lots of practice with this one. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. So first of all, are the angles congruent? Everything has a match, marked congruent. Angles congruent. Are the sides in ratio? So does 30 over 21 equal 20 over 14 equals 25 over 17.5 equals 27 over 18.9. So that's a question. Do those things equal each other? So then we're going to test them. 30 over 21 simplifies. If I divide both of those by 3, I get 10 over 7. And the 20 and the 14, both of those can be divided by 2. So that's 10 over 7. Hmm. 25 and 17.5, those don't simplify very well, but if you look at the decimal form of 30 over 21, it's 1.42857. And if you look at the decimal version of 20 over 14, it's 1.42857. So what is the decimal version of 25 over 17.5? So I'm doing 25 divided by 17.5. And I get the same 1.42 long decimal. And 27 divided by 18.9, I'm getting the same decimal. And it's not off at all. They're all exactly the same. Do those on your calculator and check them. So these are similar because all of my sides are in the same ratio, 10 to 7. Okay, so if they are, write a similarity statement. Okay, QRST is similar to JKLM. I'm matching my arcs as I went along. I went 1, 2, 3, 4, and I got to do 1, 2, 3, 4. And then we have to find the scale factor. The scale factor is what am I multiplying each side by? So like 30 times something, I'm going to use S, equals 21. 20 times S, this S is for scale factor, equals 14. 25 times S equals 17.5. 27 times S equals 18.9. I just had to find that S. So I'll work with this bottom one and I'll solve it for S. So if I divide both sides by 20, I get S equals 14 divided by 20, which is 7 tenths. 7 divided by 10, or 0.7. So that is the scale factor. 30 times 0.7 equals 21. 20 times 0.7 equals 14. 25 times 0.7 equals 17.5. Check that one. 25 times 0.7, 17.5. So my scale factor is 0.7 because I'm going from QRST to JKLM. So I'm getting smaller. Okay, do the same thing here. Triangle ABC is similar to triangle DEF. Find the values of X and Y. So I already know they're similar. I don't have to do any calculations there. But we do have to find the scale factor because it's X plus 5 times something that equals 60, but I don't know what that is. Y minus 6 times something equals 63. And 14 times something equals 42. There's the equation to start with because I know both things. 14 times something, some scale factor, equals 42. So if I divide 42 by 14, I get 3. So my scale factor is 3. So that tells me that 3 times everything in the blue triangle equals the red triangle. Not the angles. The angles are exactly the same, only the sides. So if I do 3 times X plus 5, I'm going to get 60. And if I do 3 times Y minus 6, I'm going to get 63. Okay? I want you to work those two equations out and solve it for X and Y. Go ahead and pause it. Okay, the last part is the perimeter theorem. If the polygons are similar, the sides are similar, so the sides go up in proportion, then the perimeter goes up in that same proportion. So like this one, the scale factor was 0.7. Each of those changed by 0.7 times. If you multiply the perimeter of QRST by 0.7, you get the perimeter of JKLM. So we've got MNOP and DEFG. If MN is in ratio to DE of 5 to 3, find the perimeter of each rectangle. Okay, so we've got to figure out the missing sides in order to get the perimeter. 5 to 3. Okay, so this is actually a proportion problem. Yeah, we'll do it as a proportion. So we're going to do 20 over Y minus 3 is in proportion of 5 to 3. So we're going to cross multiply that. So I'm going to get 60, 20 times 3 equals 5 times y minus 3. 60 equals 5y minus 15. 75 equals 5y. So y equals 15. So that means our side length over here is going to be 12, because it's 15 minus 3. Okay, and just check that. 20 divided by 4 is 5. 12 divided by 4 is 3. Okay. And then you can do the same thing the other way. X plus 4 is corresponding with 7.2. And that's in a ratio of 5 to 3. So then when we cross multiply, here I get 3 times x plus 4 equals 5 times 7.2. No, 5 times 7.2. 36. So 3x plus 12 equals 36. 3x equals, take 12 away, 24. So x equals 8. So then this missing side over here is also 12. So 12 over 7.2 is 5 over 3. So then we need to find the perimeter of each rectangle. So we got 20, 20, 12, 20 plus 20 plus 12 plus 12. The perimeter of the big triangle is 64. And then if I want to find the perimeter of the little triangle, I can either add them off, or I can multiply 64 at a ratio of 5 to 3. 64 over some perimeter is going to equal 5 over 3. Because if the sides are in ratio, then the perimeter is in ratio. So 64 times 3 equals p times 5. Divide that by 5, and it's 38.4. P equals 38.4, which 12 plus 12 plus 7.2 plus 7.2 is 38.4. Okay, so now you're ready to work on the next section of your ST1 assignment. And I will see you in the Google Meet at the end of the class.